Okay, so question 10. We've got compound X can be added to petrol to make it burn more smoothly. We have a picture of compound X. It belongs to a class of organic compounds. Name the class. Your functional group you're looking at here is C bond O bond C. We have an ether. Okay, a skeletal formula. So we've got the oxygen has to be given as an O, and that's attached to a carbon, so we'll stick that there. The O is attached to a carbon, which has a carbon and a carbon and a carbon. Okay. The mark scheme I think had this, was quite acceptable as well. Okay, obviously a slightly shorter bond than that one. Systematic name. Okay, this is not the nicest one actually, if we just wipe this out, because you have your longest chain here is props. We've got propane, but we've actually got 2-methyl propane, and then we've got the oxy coming off the 2 as well. So it's a methoxy, and it's a methyl group. So we've got 2-methoxy, 2-methyl propane. Okay, I just paused to go and get the mark scheme on this one. Okay, here's the mark scheme here. There is quite a lot of potential options of how you're accepting that one. So just make sure you've got one of them and then you're good. Okay, compound X can be produced by reacting 2-chloromethylpropane with methoxide ions. So we've got our formula, and we've got our methoxide ion, and we've got compound X then being created. Methoxide ions can be produced by reacting sodium with a reagent. Straight Ku for this one. This would be methanol, because we react it with the alcohol that we want to produce the oxide ion of. Okay, the reaction between 2-chloromethylpropane and methoxide ions proceeds in an SN1 mechanism involving a carbocation intermediate. Using structural formula and curly arrow notation, outline the mechanism. Okay, right, so I'm going to start with my CH3, 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 Cl. Okay, right, so our first thing is we're going to have to say, so we're creating a carbocation intermediate around this carbon here. So I'm going to move my electrons off with my chlorine. It's going to become the leaving group, okay, which gives me my carbocation here with CH3, CH3, and CH3. Okay, so since we've got a carbocation here, it's now right for attack basically, or to be attacked, and it's going to be attacked by your methoxide ion. So the minus here is going to come into attack here. It's not the nicest curly arrow, but I'm sure you can make it a little bit neater. And that will give me my carbon now attached to my oxygen, attached to my CH3, my original CH3 up here, and my CH3 and CH3. Notice I am being good about how I'm drawing these. I am not putting the H in front of the carbon because that would attach it to a bond and you can't do that. And they will be picky. Okay. Suggest why this reaction is more likely to proceed by an SN1 than an SN2. Okay, so SN1s and SN2s, the difference between this is to do with the stability of this carbocation, this positive. So basically, we could say steric hindrance and stability of the intermediate would also be what we're going with. Okay, draw an isomer of compound X that is optically active. So compound X is our whole thing here. Oh, no, okay, I can see it here. Right, for it to be optically active, it must have one carbon which has 4 different substituent groups attached to it. Okay. Okay, sorry, right. It's got 5 carbons here, so 1, 2, 3, 4, 5. Let's put the O off here. Let's make it an OH. Then that can be a CH3. That's an H, and there's a CH2. So this carbon in the centre here would be chiral. That would work. There are lots of other ones that you could do. Anything that fits the numbers is basically what you're looking for. Okay. Lowrise Nmr for compound X. here we've got this one. Complete the spectrum by drawing one line to show the correct chemical shift and relative intensity for the other hydrogen environment. Okay, so I'm just going up here so we can see this. So in terms of hydrogen environments, okay, we have 3 hydrogens in this environment, okay, and then we have 3 here, and 3 here, and 3 here, which are all in the same environment. So we have a 9-to-3, okay, so a 9-to-3 is obviously a 3-to-1, okay, we're going, so that's obviously a 3-to-1. Right, give me just a second, I'm going to go and get the databook page. Okay, quite likely, I have no idea how long that took me to clip around with this thing. Okay, so this is, we're looking at our, just basically our CH3s attached to R groups. So we're looking at the top line. I only actually pulled out the bit that I needed. Okay, so we need something between 1.5 and 0.9. Now this actually, when I look at this again, actually this is at a relative intensity of 3. So we want a relative intensity of 9, 4, 5, 6, 7, 8, 9. So up here, and we want a line anywhere between 1.5 and 0.9. So if you've done a line, there's no way this is going to be straight when I do it. Okay, but so a very wobbly line, but you do get a perfectly straight one. Intensity 9 for it to fit. Okay, yeah, as I say, that's actually 9-to-3. Okay, and that's it. Okay.